Okay, we're going to do the same thing here, but it's for cos. So double angle of cos A plus B and cos A minus B. Now, the only difference is, you'll notice, again, these are both given to you by the SQA, is that cos A plus B, this is really important, actually goes to a minus. Okay, and then cos A minus B actually goes to a plus. So just one wee thing to watch out for, because it does catch people out, okay? And again, it's on your formula sheet. We'll talk about how it's shown later on, but just watch out for that. So in cos, it's the opposite. Minus goes to plus, plus goes to minus. And it goes cos, cos, sine, sine. So cos x minus y must be, so it's cos, cos, plus though, because it was a minus, sine, sine. Okay, you can't do it in that one, so we just leave it as it is. Okay, do the same here. So cos, cos, plus goes to minus, sine, sine. Okay, so this is when our exact values comes into this. So we're going to work them out like I did previously. We actually did tan of 315. We're going to do sine and cos. So cos of 315. So the first thing is going to be 360 minus 45. Okay, so again, what you're saying is, okay, is it the same as cos 45 or negative cos 45? That's the question. Let's draw a wee quick cos graph. Okay, where's 315? Well, that's 270. We know it ends there, so 315 is in there, which is positive. So therefore, cos of 45 is 1 over root 2. Okay, we do the same with sine of 315. So the question is it sine of 45 or negative sine of 45? Quick sine graph. Okay, where's 315 and sine? It's obviously going to be down there because it ends at 360, which is going to be negative. So it must be the negative of it. So negative 1 over root 2. So chucking them in, we're going to have... Now, I'm going to put the right way down just for ease. So you'd always put your number at the front. So cos of 315 is 1 over root 2. Just figure that out. I'm going to put it at the front. Minus, right, double negative, make it a plus. 1 over root 2 sine x. Always watch out for negative numbers in higher maths. Right, example 8. So it says, show that pi over 3 minus pi over 4 is pi over 12. Now, at any point, if you want, right, you can just eliminate your fractions. Eliminate the pi's, and then, okay, a third take away a quarter, is it a 12th? Is an easy way to do it, right? We can obviously do it with the pi's, but if you just quickly do it without, obviously we'd make them both into 12s. So 4 over 12 minus 3 over 12 is obviously a 12th. And then just chuck your pi's back in. So at any point, you don't have to keep the pi in it. Just take it out and then obviously it goes back in. But if you wanted to keep the pi, again, we're just going to times them by 4. Just because I know it sometimes looks a bit more confusing, even though it's not, but it can be. Four pi over 12 minus 3 pi over 12 is pi over 12. Okay, as proven. Easy. But again, at any point, just take out your fractions. Okay, not a problem. Take out your fractions, keep saying that. Take out your pi, and then just work with the fractions. So then it says, hence, find the exact value of that. Now, hence comes up all the time in higher. What does hence mean? Hence means use what you've just done. So why have they made us do this? Because they're saying that pi over 12 is the same as pi over 3 minus pi over 4. So let's think, right. So cos pi over 12, using the word hence, really important. They're saying that is the same. We've just proved it. It's pi over 3 minus... No, it's messy. Pi over 3 minus pi over 4. Okay, why is this important? Because a wee light bulb will go off in your head and say, oh, that is the same as cos A minus B. Okay, whereas that is A and that is B. So we're going to use that formula. I'm going to chuck it in. So what do we have? We have cos A, cos B, minus goes to a plus, sine A, sine B, Okay, your brain will be going, oh, these are the exact values. Okay, whenever you know them off by heart or you memorise them, you know your triangles off by heart or you memorise them. Now, if you want at any point, you can just say, oh, look, that's 30 and that's 45. Okay, so cos, 60. Cos pi over 3 is 60. So cos of 60 degrees is 1/2. Cos of 45 is 1/√2. Plus sine of 60 is √3/2. So again, you would write down your triangles or you just know them. Okay, I just know them. 45 sine or cos is always 1/√2. And then we just tidy it up. Same denominator. Can't tidy up the top though. Just put it over the same denominator. And that is you. Okay, so the key is you need to know your exact values. Non-calculator work all the time. You really, really need to know them. Now this is how it is given to you by the SQA, okay? Really important. Let's change my colour. Okay, and again, as I stressed earlier, plus or minus there goes to plus or minus. In cos, plus minus, minus plus. Okay, really, really important. This is how the SQA give it. So every time this comes up, you're like, oh, turn to the front, get up.